Hi, and welcome to section 4.12, Comparing Strings and Characters. I'm Professor Stiller-Schulman. Let's get started. Characters are compared using their ASCII values. ASCII is a subset of Unicode. And in the ASCII system, each character is given an integer value. There are 256 of these integer values. The ASCII character value for capital A happens to be 65, and the ASCII character value for B happens to be 66. And so we can make the claim that the character A is less than the character B, because the ASCII value of A, 65, is less than the ASCII value of B, 66. Believe it or not, the ASCII value of 1, the character 1, not the number 1, but the character 1, some trouble with characters here, let's see. Is less than the ASCII value for the character 2. The ASCII value of the character 1 is 49, and the ASCII value for the character 2 is 50. Lowercase letters have higher ASCII codes than uppercase letters. So, which direction should the relational operator go between lowercase a and capital Z? Well, since lowercase letters have higher ASCII codes, lowercase a is greater than Z. Just like characters, whole strings are compared using their ASCII values. So let's take a look at this example code where we declare a string variable called name1 with the value Mary, and the string variable name2 with the value Mark. Both names start out with M-A-R, but the last letter is different, the Y versus the K. So let's take a look at some expressions and see if they're true or false. Name1 is greater than name2. Well, name1 is greater than name2. What do you think? Well, the ASCII value for Y is greater than the ASCII value for K. So that means this statement's going to be true. So Mary's greater than Mark. How about this statement here? Name1 is less than or equal to name2. And name1 is not equal to name2. Well, name1 is less than or equal to name2 would mean that name1 comes before name2 in the dictionary. Or that they're the same name, but we can see that that's false. And how about this last expression, name1 is not equal to name2? Well, the two names are different, so that statement is true. Let's keep comparing strings by creating a C++ program that uses relational operators to check whether a string entered by the user is a valid stereo part number. In this program, we'll need to include IOStream and also string. In the main method, let's declare two constants. They'll both be doubles, and the constants will represent the values for the price of stereo system A and stereo system B. And they'll just be price A and price B. Stereo system A costs $249. Stereo system B costs $299. Let's prompt the user for the part of the stereo they wish to purchase, or the part number of the stereo they wish to purchase. Not just the part, I guess you can't just get a part of a stereo. So enter the part number of the stereo you wish to purchase. And then let's use cin to read in whatever their response is. And let's store that response in a variable called partNum, which is going to be a string. So they're going to enter whatever stereo part number they want, and it's going to get stored to partNum. And the part numbers for the different stereos are S-29A, I'll put them up here with the prices. Price A is for this stereo called, with the part number S-29A. And stereo B, the part number is S-29B. So hopefully they enter one of those, but if not, we'll validate their input. And we'll print out that's not a valid part number if it's something other than those two. Otherwise, we'll just print out the price of it. So now that we've read in the part number, let's set the numeric output formatting. So we'll also want to include IOmanip. And let's just stream out some stream manipulators. Fixed, show point, and set precision to 2 for the dollar amounts. And then now let's determine and display the correct price. So if part num is equal to S-29A, then we'll want to see out the prices and then price A. Can you finish the code that will print out the price of stereo B if the user enters its part number? And after that, challenge yourself to write some code that will print out part num is not a valid part number, so whatever part number they put in, to print out that it's not a valid part number if it's anything other than these two. You can pause the video to finish. Similar to the first check, let's check whether the part number matches stereo B by seeing if the string that they entered is S-29B. And if it is, we'll just print out price is and then price B. How about the case where they enter something that is just not one of the part numbers at all? Well, we can deal with that with a trailing else. If part num was anything other than those two possible, options, then let's just print out part num is not a valid part number. And then just a new line character. Let's end that line. Okay, so there's our program. It uses relational operators to compare a string entered by the user with the valid stereo part numbers, and then determines and displays the correct price if they enter one of the valid numbers, or prints out whatever they entered is not a valid part number if it's something other than those two options.